Hey everyone, my name is Alexa, and we built this machine learning model which tries to predict the S&P 500. And in this video, we'll talk about what we did, which models we use, and which models actually work the best.
So the project structure was to compare two complex models, which were the random forest and feed forward neural network, with the base model, which is a logistic regression. And we tested these models against a benchmark model, which is just to buy the stock and hold it. And we tested those in S&P 500 stock. And the data was extracted from Yahoo Finance from 2010 to 2025.
So to help these models and understand the data, we had to create five mathematical features, which are the MACD, which measures momentum, and it tells us whether it's speeding up or slowing down. The trend, which compares the today's price to the 30-day market average, like are we up or are we down? And the volatility, which measures how nervous the market is based on the recent price changes. And then the momentum, which is the average change over the last 7 days, and the target, which is a binary value, which represents whether we were up or down.
So for the hyperparameter tuning, we use grid search to find the best hyperparameters. Some of the hyperparameters were unified, for example, the buy and sell thresholds, and some of them were uniform, for example, the trees for the random forest, and also for the learning rate and epochs for logistic regressions feed for network. But also there are only ones that only apply for feed for a network, which is neurons, a number of neurons and hidden layer size.
So the first model was the tree search, and the second two models are the logistic regression and the feed-forward neural network. The logistic regression is like a single layer, and you can think of it as drawing a line between the buy data points and the sell data points. And the FFNN adds a hidden layer with 32 neurons and a ReLU activation. That lets us learn more complex and curved patterns rather than just a straight line.
So the implementation phase was to train these models from on data from 2010 to 2017, and we use the data 2018 data to for the validation testing, which is to turn the hyperparameters, and then we test them from 2019 to 2050 to 2025, and then we plot all the curves, the lines in one graph on all of the years.
So why this architecture? So there's no look-ahead bias. By cutting the training at 2018, we don't let the models peek into the future. And then the ensemble comparison. We run all the models separately, and then we can compare whether we are up or down based compared to the market average or the buy and hold method, and compare like which models are most reliable and which models have the highest earnings. So these are the results, and the tree search method is the most reliable one, which is what we expected. And it was followed by the FFNN and then by the logistic regression. But the FFNN and the logistic regression are very susceptible to the random parameters that are at the starting of the training.
And that we compare these results with other papers, for example, from Wang and Shi, and they found out that the random forest model was performing better than logistic regression, and and the reason why random forests maybe perform better in these cases because financial data is highly anticipated, and a neural network usually try because of their complexity they try to learn the noise and try to overfit, but random forests they don't do that, and also they don't need to normalize like for example neural networks. And here's our resources, and thank you for watching.
Yep.